Let's begin. Today's December 31st, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria cards 4, 8, 12, 18, and 21. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. Criteria card A takes a look at our middle digit, the square digit, and the Turing Machine will be comparing the square digit to the number 4. Should the value of square be less than 4? Should it be equal to 4? Or should the value of square be greater than 4? Criteria card B will take a look at the 3-digit solution, and the Turing Machine will let us know how many 1s there are. Are there no 1s? Is there a single 1? Perhaps 2, maybe even all 3 are 1. Criteria card C will take a look at our first and last digits, triangle and circle, and the Turing Machine will be comparing them. Should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D will take a look at our 3 digits, triangle, square, and circle, add them up, and the Turing Machine will let us know if the sum total is an even quantity or an odd quantity. And finally, criteria card E again takes a look at our 3-digit solution, except this time it'll let us know a little bit about the code structure, so to speak. Specifically, it can inform us of 2 possibilities. The first is that there is a pair in our solution, as in the example 131, or alternatively, there are no pairs, but there are 2 cases. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card D. Okay, so the Turing Machine does not approve of my choice in proposal. Notice that in criteria card D, we are adding up all the digits. So let's go ahead and do that. So 3 plus 1 is 4. 4 plus 4 is 8. 8 is an even quantity, but since the Turing Machine does not agree with that, the Turing Machine is letting us know that the sum total should actually be an odd quantity. So let's go ahead and type that up in our notes in section D. And we'll state that triangle plus square plus circle should be an odd quantity. Well, it may be a bit too early, but let's give it a try to see what can we discover from the result. And that is that if we want the sum total to be an odd, that means there are a couple of scenarios. One, the first one, the most obvious one, is that all 3 digits must be odd. And the second case is that you have 2 evens and then an odd. And that's because when you add 2 evens, sure, that sum is even thus far, but when you introduce a single odd, that means that the sum total would be odd. So we're looking at a potential solution that's either an all odd solution, or we could have 2 evens and an odd, and of course in some order. We don't know the ordering as of yet. The next thing I think I'd like to test is criteria card E. Okay, so the Turing Machine does approve of my proposal. Notice that in 314 I have no pairs, and the Turing Machine agrees with that. So let's type up that in our notes in section E, and we'll state that the solution has no pairs. Okay, But there are two possibilities. Remember that either they can be all distinct, as I have, or it could be a single digit repeated 3 times. But I don't think it could be a single digit repeated 3 times, because if that were the case, then we would know criteria card C that both triangle and circle would be equal. So I think, and that would make this card irrelevant. So for that reason, I think we can safely say that the 3-digit code must be all distinct digits. And let's see. So again, thinking back, we do have the possibility still that we have 2 evens and an odd. Those could all be distinct. And we could also have an all odd solution. So let's think about that. If there are no ones, if it comes back to be false that there shouldn't be, well, at this point, because they're all distinct, we know there can't be 3 ones or even 2 ones. So either the 1 is there or it's not. Now here's the interesting thing, is that if a 1 is not present, I don't believe we could have an all odd solution. Remember, they do have to be distinct. So if there is no 1, sure, you could have a 3 and a 5, but then that 3rd digit would have to be even. And when you have 2 odds and an even, that sum total is even. So it would be quite informative if it's false. Notice that in my proposal, I do have a 1. But if I test criteria card B and comes back false, that lets us know that we do have 2 evens. So it may be worth a risk to test criteria card B. And let's see what happens. Okay, so it does approve of a single 1. Okay, so that somewhat kind of backfired on us, and that doesn't inform us whether it's an all odd or 2 evens and an odd. So, well, it was a risk I was willing to take. So let's go ahead and type that up in our notes in section B, and we'll say that the solution has a single 1. Okay, so we do know we have a 1, but we still don't know if it's an all even, 2 evens and the 1 or not. Okay, well, I don't think we can, we didn't really cross out anything in this first round, but we're going into the second round with some good information. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing that middle digit to the number 4. We also did not test criteria card C, comparing triangle and circle. Well, at this point, we know that they can't be equal. They do have to be distinct. And so the first thing that really kind of jumps at me is that, well, it would be pretty nice if we knew that square was equal to 4, because then that would establish that one or the other digit would have to be the 2, and then the other digit would be the 1. So if square is 4, and then we could then use criteria card C to place the other even or the 1 based on how whether triangle is less than circle or triangle is greater than circle. So we'd be looking at something like 1, 4, 2 or 2, 4, 1. And that's if, in fact, it's equal to 4. It may not be, but let's go ahead and try that. I'm going to type up 1, 4, 2 as a possible solution. Okay. Well, the whole reason for that proposal was criteria card A. Let's see if we're lucky this time. It is not equal to 4. Okay, well, that did not work out. So let's go ahead and type up, since we know it's not 4, then let's see, that was criteria card A. So we'll say that square should either be less than or be greater than 4. So let's go ahead and cross out the 4 in square. Okay, so obviously with 4 out of the way in square, the likelihood that we do have 2 evens is a bit reduced. But let's see what else. Well, let's go ahead and test criteria card C. Hopefully that'll help us eliminate some other digits. Okay, so that is also incorrect. So notice I did pick a 1 for triangle and 2 for circle. So my choice of triangle being less than circle is incorrect. We also know that they can't be equal. So we can actually deduce that triangle should actually be greater than circle. So let's go ahead and type that up. And again, we'll say that triangle, or actually we're going to type up that we're going to deduce that triangle should be greater than circle. So triangle should be greater than circle. And so what can we say about that? Well, I don't think circle could be 5, because if circle were 5, there's nothing larger for triangle to be. And similarly, I think we can say triangle can't be a 1, because if triangle were 1, there's nothing smaller circle can be. So we've eliminated those 2 values. So let's see. And remember now, we do have a single 1, and now it's either in square or circle. So let's see, if square were perhaps maybe greater than 4, it would make that 5. It would force circle to be 1, and then triangle could be 3. And I guess I should say that at this point we're done for this round, because B, D, and E are well established. There's no reason to test them in this round. So I was only able to complete A and C in this round. So now I'm kind of talking through what could be a possible 3rd round proposal. And so far, the most convenient or the easiest possibility is to let square be 5, again forcing circle to be 1, and then triangle be 3. So we're looking at 3, 5, 1 as a possible solution. Let's see, what else could we, that's the most obvious. I think there may be many more, but let's see. So, and that is convenient, because that's the only possibility where triangle would be greater than 4. I meant to say square is greater than 4. Well, if square is less than 4, let's do the possibility. But how would you know if it's even? Again, that would be clue. Like, it could be 4, 2, 1. But why would that? How would we choose? Oh, remember that triangle does have to be bigger than circle. Yeah, so 3 is bigger than 1. So that's okay. If it were, maybe there are just too many possibilities. I guess let's see. What if square were 1? Because let's see, could circle 1 be is that the only possibility of circles 1? I guess probably not, because you could have, I guess you would pick between 2 and 3. Yeah, you'd pick between 2 and 3. We already did the 5, so it couldn't be 1 for squares, so it'd be 2 and 3. So it'd be 4, 2, 1, and then 3 would be 5, 3, 1. And so can we categorize those as ambiguous? 5, 3, 1, and 4, 2, 1. Well, they all have a 1. They're all 5, 3. Yeah, 5, 3, or 5 is bigger than 1. Yeah, they're all bigger. They all be less than. There's a 1. Yeah, I don't see how you could distinguish them. Yes, I don't see how you could distinguish anything less than 4 for square and, picking the respective triangle values. Now, what about, so that dealt with circle being 1. Now, if again, we'd have to pick something that's less than 4 for square, but this time we'd pick the 1, and we'd have to have, at this point, if square is 1, can we still have evens? Yeah, I guess you could still have evens. You could have 4, 1, 2. 4, 1, 2 would work. But not 3, 1. But 5, 1, 3 would work. 4, 1, 2, 5, 1, 3. And yeah, I think those would all be ambiguous as well. 4, 1, 2, 5, 1, 3. Yeah, all those values, triangle is larger. No pairs. And and 2, 1, 4 would fail because 2 is not larger than 4 circle. So that would fail. But yeah, there seems to be too many ambiguous solutions. So I'm going to state here that we're going to deduce that square should actually be larger than 4, making it the 5. And here, let's see. Yeah, because I think that's the only outstanding. Yeah, that's the only outstanding possibility. What would square be? So let's go ahead and type that up. I'm not going to cross out the digits. So I'm just going to say 3, 5, 1, and let's go verify. So 3, 5, 1. Okay, yeah, so all the work did pay off. Well, how did we do versus a Turing machine? Well, this is a 5 criteria card puzzle, and we did exactly 5 tests. So that's always promising. We could have tied and won, or we could have just outright beat the machine. So in the first round, we did test B, D, E, and in the second round, we did the remaining 2. And in the first round, D was the only incorrect, and both A and C were incorrect. So let's go ahead and type that up. So B, D, E in the first round. And in the second round, A and C were incorrect. So my initial thoughts on my solution were incorrect, but we pivoted and we solved it correctly. Okay, yeah, so we beat the Turing machine by 1 question. So no doubt, obviously some of the deductions paid out, and it helped out just to test out what would happen if square were bigger. That was the one that was sort of remaining, that was maybe easy to understand if square were 5. And once we established that, then we knew we'd have an all-odd solution. Well, what about you? How did you solve it? What criteria cards did you choose? And did you discover anything interesting that you'd like to share? Please add those thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.